Hello everyone. Very good morning to today's webinar on Hadoop to Azure Databricks migration. Uh, we are almost ready. We will just give like another 30 to 45 seconds for other attendees to join, and then we'll kickstart immediately. Thanks for your patience. Okay, all right, let's get started. Good morning, Pandian. Good morning, Vidya. Thanks for joining this call really helpful that we would be discussing today on Hadoop to Azure Databricks migration. So again, good morning, everyone, and good afternoon, good evening for who are joining from different parts of the world. Uh, and welcome to today's webinar on Hadoop to Azure Databricks migration. My name is Noor Basha, Marketing Director at WinWire Technologies, and I will be your moderator for today's webinar. As you all know, today we are discussing around Hadoop to Azure Databricks migration. In the next 45 minutes, what we will do is we will basically discuss around lake architecture and also some of the best practices in terms of migrating Hadoop distributed data frameworks to Databricks. Before we start, let me highlight a few housekeeping items. During the webinar, please feel free to post questions and we will try to answer as many as we can at the end. And we are recording this session. We'll be sharing that to you in next 24 to 48 hours. Also, this will be available on our website as well as on our social channels. Without further delay, let me introduce you to today's session speaker. I have Pandian, and just Pandian, who is the Vice President for Data and AI at WinWire Technologies. And he basically focuses on building platforms and solutions that delivers value to our customers. I also have Vidya, who leads our Databricks practice, helping customers adopt Databricks for engineering, analytics, machine learning, data sharing, and governance. So just a quick note, we recently, WinWire was recognized by Microsoft in a couple of awards. One was we were Microsoft Partner Award for Healthcare across the US. And we were also nominated as a finalist for healthcare as well as cloud app modernization. So again, it's all because of the good work that's being delivered to the customers and the value the customers are seeing with these solutions. So let me, before we start and I hand it over to Pandian and Vidya, let me quickly take a minute to start out with a poll in terms of like quick 20 seconds. If you could just fill in the poll and we will quick start from there. All right, we are almost, we'll give few more seconds. Got it. So close, I'm sharing the poll. So this is the poll results of, and what I would do is I would hand it over to Pandian to take it from here. He would start off discussing about this poll and the agenda and the next session from here. Pandian, over to you.
Yeah, thanks, Noor. So I think we did get a message that most of the Hadoop environments, at least whom we've been talking today, are more than petabyte. So that's good to know. So looks like there is a large Hadoop environment in place in many deployments, right? So in today's session, we will, to start with, we'll briefly look at how does Hadoop Databricks ecosystem has evolved, what are the challenges, and how Databricks as an ecosystem delivers value to organizations, right? We'll look at it, and then look at specifically what are the specific migration challenges, uh, what are the considerations to ensure those challenges are handled effectively, and specifically for each of the tool sets in Hadoop, what are the migration aspects to be considered. So that's something we'll also cover today, and also have a brief demo on a metadata dashboard. So basically, a dashboard that shows analyzing the Hadoop environment, and then we also will briefly talk about a success story in terms of how we help the customer transform their existing Hadoop to a Databricks environment. Right. So with this, let me quickly go to the next slide.
We can't, we are still on the agenda slide in case if you
Yeah,
have moved.
I'm seeing this. No. Looks like it's stuck. Yeah. So sorry for the delay. Yeah. So this slide summarizes in terms of how Hadoop has evolved, right, and into different COTS product. So if you've been following up on Hadoop as a platform, we could say that kind of started our adoption probably across organizations widely in enterprise level probably from 2008-9 onwards, when Cloudera became the first COTS product based on Hadoop, right? And thereafter there has been multiple products which have come in, Hortonworks, Mapr, and if you see the current state, there has been a lot of consolidation, and probably Cloudera is one of the major independent player in the Hadoop space. And Hadoop, as we all know, when it came into the market, it was more how we could do batch processing much more effectively, handle large volume of data, varieties of data, right? At the same time, parallelly, you could see that somewhere in between 2013, Spark became an Apache project, and then Databricks as a commercial version of that with much more better performance was launched, right? And now you have Databricks as a native service on Azure, right? And at the same time, when Hadoop on-prem and Spark was evolving, the cloud also kind of came into the market, and all the Hadoop services, be it Hive, running Spark, or running an H-based query, all of them all of them also were available as a service on the cloud, right? So starting from EMR and Amazon, or now you have Azure HD Insight, which helps you run Hadoop services on the cloud, right? So, and as we all know, those Spark was seen as an in-memory, more suitable for real-time. Now it has evolved to a space where both batch, real-time, and there are multiple, all workloads, different kinds of workloads are being addressed by Apache, Databricks, Spark as a platform, right? So with this, let me move to the next slide. So this slide summarizes the typical kind of widely used tool sets in Hadoop ecosystem, right? So HDFS file system, HBase, or Scoop and Flume for data ingestion, Hive for queries, or Pig for ETL processing, right? So these are kind of widely used tool sets, and if you take any of the customers who started started their Hadoop environment 5 years or even 10 years before, this will be the common set of tool sets in their environment. And as they have evolved, right, most of the Hadoop environments at this point of time would have maxed out in terms of what was planned as a capacity for them. On-premise 5 years before or 10 years before, what was planned as a capacity, they would have maxed out, right? And the very reason of it requires them to add new nodes or see how that can be scaled up. So the key challenge in this current ecosystem is in terms of scaling up their existing environment to a much more newer capacity handling, right? That's a challenge, because it requires, now with cloud being available, for you to look at enhancing or scaling up your on-premise is a costly option, right? And Hadoop by design had a lot of tool sets each for its specific workloads, right? So you had certain tools for streaming, certain things for batch, and for ML capability, and all of this required certain administration capability. Though there are COTS products available, but each of them required their own ways of supporting, managing, administration it, right? And so the environment becomes quite complex. So in fact, now if a customer is running his enterprise data lake on Hadoop, he would spend a lot of time in managing those two code base and ensuring that each of them runs in an effective way. So, and since Hadoop by itself didn't have a good ACID support for update kind of actions, uh, teams tend to develop different workarounds, which becomes a much more complex process to run and manage the process, right? And though Hadoop was initially seen as a platform which can also support analytical activities, but during the course of adoption, it became more of a data lake platform. So the integration or reporting platforms like Tableau, Click, Power BI, right, connecting to an Hadoop system is limited in terms of how they interact. They were not more for interactive analysis, more for batch process. So that's the reason why Hadoop, wherever you see a Hadoop data lake, you would see another database, relational database existing there for analytical reporting or curated reporting. So, and Databricks, if you see that in terms of layers, data storage, data processing, data interface, is similar to an Hadoop ecosystem, but the key difference is in terms of all the processing is in memory, which is the data processing layer, and the data storage is kind of becomes more independent, right? So it could be in Azure, it's on a data lake store or a blob store, and most on all the files managed in Paki format, right? So the storage is managed by the cloud platform, and the processing and the interfaces which are is what delivered by Databricks system, and this kind of directly addresses many of the challenges which were there in the Hadoop system, since it was all on the cloud as a service, right from very initial stage. So the scaling up or scale down is directly delivered by a cloud platform. And in terms of different kinds of workload, batch, stream, or ML, so all of those are available in a single workspace. So the way of managing code or running it or delivering the performance is all within a single platform, which made things easier to manage, right? And with the recent Delta Lake and Delta Engine support, you could run SQL queries in an interactive manner, and it provides a full update as it support. So these all made a lot of differences when compared to an Hadoop ecosystem. Now, the other major difference is in Hadoop, you would actually have a relational data structure for reporting. With the Lakehouse architecture, you could actually directly run queries on Delta Lake, which also kind of made additional data storage or different technologies to be brought into the overall architecture. So with this, we kind of understood uh, the different ecosystem of tool sets, challenges in Hadoop, and what Databricks brings together, and how it produces a unified experience for end users, either be a data engineer, data scientist, or a data analyst. Now, if you have to look at, if I'm going to migrate from Hadoop to Databricks, what are the key things of scope which I'm going to look at, right? So there are three aspects to it. One is Hadoop metadata. When I say Hadoop metadata, it's the data model, the data structure which is stored as Hive structures, right? That's the one. The other one is data process, the actually data engineering process, be it big scripts or Hive queries, which is preparing the data, uh, or Scoop and Flume process. Those the data process, and then the interface apps. Interface apps is though there are limited, and I would say in terms of reporting tools talking directly to Hadoop's ecosystem, but there are certain interfaces through which data can be consumed. So those are the interface apps which needs to be looked at. So all the metadata related to the the engineering or ETL, the reporting, and the actual data models, the Hadoop metadata. The second is Hadoop being a platform for managing huge amount of data. Definitely, in fact, really in aligning to with our poll today, much of the data is more than petabyte of storage. So data migration being seen as a separate uh, track is very important. So that's the second scope of work which needs to be looked at for migration. The third aspect is which is kind of limited in Hadoop environment, be it security or governance, but that becomes very important in the cloud. So when we migrate an Hadoop to a Databricks environment, it's to a cloud platform like Azure, it's very important that we also look at the security and governance. So that's the third aspect to be looked at to ensure all of these three are addressed for a successful migration to cloud. Right? Now, so we looked at the scope of work for a migration. So there are three aspects. But what are the typical challenges when we look at migration? So one is, especially when a system has been built for 10 plus years and there has been a lot of hand coding done, for us to get to know what's happening in the system is not very easy, right? And if we put together a plan without understanding those risks, and there could be a lot of unknowns which will probably help us, which will not help us. So we might end up facing issues or facing challenges which might be very difficult to handle with a planned timeline, right? So that's one risk we see in many migration projects, but it's very much required relevant for an Hadoop environment, which has a lot of hand coded programs being done, right? The second aspect is, if the system has been in place and it's being used widely by the business, and if the system has been maxed out, especially if the existing Hadoop environment has maxed out, then extracting data, pulling data from it, ensuring the data migration activity, right, is not impacting the BAE is also a very critical task. And especially if the data has been transferred through the network, you need to ensure that doesn't impact the day-to-day business work. So this is also a challenge which has to, when I say challenge, it's not something which cannot be handled. Definitely it can be handled, but it has to be planned effectively. The third aspect is, if you have done a lot of coding on, if you could have even done some Spark programming in Hadoop environment, right? You have done a lot of programming in Spark or Pig, then there's going to be some good amount of manual intensive conversion process, right? So it's very important that we understand that process, how much of that can be automated, getting a handle of what kind of skill is required, how do I plan a good amount of validation process to that activity if I'm going to rewrite, re-engineer those code, right? So that's also an important aspect to be looked at, and which is actually a challenge, if not handled effectively, can actually derail the project. And the last two, I would say, is most to ensure that the work we deliver as part. The first three is, I would say, it's more of to ensure that the project is success in terms of migration. The next two is in terms of security, integration, governance, and optimization, is to ensure that the whole system, when it's moves to cloud, it's adding value to the whole environment rather than pure migration. From that perspective, security, how it integrates with other services in the cloud, and how is the governance mechanism, and ensuring that the newer capabilities of platform, especially for Databricks with now Delta sharing, Unity catalog, how Delta live tables, how these things can be leveraged also should be thought through. And in fact, this could also be a good opportunity for building a business glossary if it's not already in place, so that the system can be more, the data within the system can be made available to a business in a self-service mode. So now we have seen the challenges. So how do we ensure, what should we consider as part of our migration process to ensure this migration, to ensure it's successful and also it's add value to the overall migration process, right? So we could look at in 6 aspects to see if we can look at these 6 aspects as part of our migration process, we would be much more closer to a successful or a valuable migration project, right? So one is to ensure that we get a deeper insight, not look at a surface level, but get to the deeper in terms of what's my current system, where are the challenges, which could have more conversion challenge, which could have require more validation aspect, which would require some domain knowledge for me to actually pass through the migration process. So getting to understand that and plan a migration is very important. And as part of that planning migration, we should also focus towards building a pilot. So we should do a small pilot project, and learnings from that has to be part of the overall migration planning. The other aspect is, with Microsoft's well-defined cloud adoption framework and toolkit, it's very much important on an Azure platform. So the good amount of learnings and best practices from there are applied as part of the migration engagement. And to what we saw is a lot of manual process getting involved. We should look at, with the understanding of an existing environment, what kind of tool sets can be brought in for assessment or conversion or validation to automate the existing process. And the other thing which we have seen is, which is also not focused a lot initially, because if it's seen as a more IT driven engagement or program. So what we tend to lose is when we validate the applications, right? So a good amount of business knowledge embedded into the team will help do certain validation process much more quickly. I think that's also something which has to be planned as part of the overall migration team structure, that we are bringing some business knowledge into the existing team. It's not experts, but a team who kind of goes through a own process to understand what the business data is, what kind of constraints could be there for a better validation process. And the other two, which is very critical, is to ensure that when an organization is moving from an on-premise Hadoop to a cloud Databricks kind of environment, so the way they interact with the tools, how they're going to run the systems, how they're going to manage, is all going to be very different on the cloud environment. So it's very important that the business and IT go through the change process to understand how this new system is going to help them, and also help them do more than what they've been doing earlier. And the other thing which will add a lot of value to the migration project is to ensure that we're able to leverage certain new capabilities of the platform, so that it's not just a one-to-one migration, though it's functionally it might be doing the same thing, but getting an additional capability to the platform, along with within as simple as creating business glossary for the business to creating a wiki page, right? So that you could actually democratize data for everyone to come and look at the data, which is probably you had hundreds of users. With this information, probably you could bring in an additional 20 users, which is a value to the migration project. So, and what at WinWire we have done is we have taken these key aspects, and then our migration as a service is a framework which adopts all of this. And we will look, this framework as such looks at infrastructure, application, data platform, collaboration in an enterprise. But our discussion and following slides is specifically on the data platform. So we saw what are the challenges in migration. We saw what are the key aspects to consider when you're looking at to address those challenges. Now, if you're going to put together a phase, right? What are the activities, tasks which I have to perform if I'm going to do an overall execution of migration, right? So if I have to start from Hadoop and move to Databricks, I would say there are 4 steps to go through, right? One is to assess. I think these are quite simple steps which we go through in any of the project, but there are certain key pointers which we want to highlight as part of this particular discussion. So assess is to look at the Hadoop environment, just create an inventory of what it is, ensure you're able to get to the details of visibility into the complexity of the environment. Are there any redundant process? So this could be a 2 to 4 weeks exercise based on the environment. And here we can actually do a level 0 planning. So you could actually do a level 0 initial planning, and this could help you put together, because since you have the inventory, what tool sets are used, where the complexity is, where there are challenges, where things are going smooth. With that understanding, you should be able to put together an architecture and what are the Azure services I'm going to use, what Databricks components, where it's going to fit, what is the overall blueprint. So that could be done as part of the architect phase. And this is where we'll also define, based on the understanding assessment of the existing environment and based on the architecture, what is the right scope for my pilot project, right? And pilot could be a boxed 4-week exercise where we look at a small use case, do an end-to-end conversion of an Hadoop environment to a cloud environment, to a Databricks cloud environment, and then see whether it's working end-to-end in a proper way. And this is where pilot is where I would actually finalize my whole migration plan and actually put together in a service model where I could actually start doing migration in waves. And typically we could look at a 4 weeks per wave kind of a migration, which could be by subject area, or it could be based on a functional area where I could actually look at a set of independent table sets, file sets, data sets, and queries to be migrated to the Databricks environment, right? And each of the phases, there are specific tasks and outcomes which are highlighted here, which are very critical or unique to the Databricks and Hadoop transformation engagement. So now we know what we have to do. So assess, we have to architect, do a pilot, and then go into migration waves, right? As part of this exercise, there are certain basic fundamentals which we need to kind of have it in hand, right? But so yeah, these are options. When I'm going to move from Hadoop to Azure Databricks, what are the options available? But these can be kind of customized. So let's say you have HDFS, your storage will be in Azure Data Lake Store, right? But if you have a Spark program, you could still move them into a Spark on Databricks. If you're already having them in that could be certain changes required, which we will see in next few slides what those kind of changes are. But here again, you have an option. You could still write them in Scala, or you could, if you want to write them in an ADF, there's an option to do that, right? In ADF also you have data flow, which leverages Databricks at the backend. So if it's Hive, you could look at some of those queries getting into a data lake queries, or you could have them as Spark SQL queries, right? But if you're you're looking at to bring an analytical platform integration to the into the Databricks, then a Delta Lake query is the right option because it supports SQL and interactive analysis, right? And typically a scoop process can be you would have scoop script for moving the table files. Here you could probably write this and complete an ADF process, or you could use autoloader or copy into function from Databricks, right? Similarly, Flume. Flume could be again ADF process, or it could be if you're looking for more real-time streaming kind of work, then it could be a Spark Stream kind of model also, right? So these are some of the, and you could use Impala if you're using Cloudera. So there could be other tool sets which can be used, which might be in use, but these are the, and if you're using Pig, there are some instances where I've seen customers using Pig, then probably you would look at rewriting them in Scala Spark SQL kind of model. Right? So these are some certain fundamentals which you will have it in hand, so that when you go to the architect phase, you know. So the Hadoop column is what you would find in the assess phase, and what mapping to what service is what you will do the Hadoop in the architect phase, right? And if you feel some of those are having, you want to evaluate which is better, that's what you will do in the pilot phase to validate which is more suitable for your environment. And now we'll go through that specifically. We looked at the scope of area, right? One is metadata, data, and management. So now what we're seeing is within the metadata, the data model space, right? So in data model, what we're looking at is the Hive structures are to be moved to Delta Lake equivalent structures, right? From that perspective, what would I analyze, and then what would my conversion happen? What would I validate? Right? If you're looking at these three aspects in as a migration approach for data model, then my Hive structures, SQL queries, whatever listed here is what we have to analyze, and then convert them into equivalent Parquet files, and then have a equivalent Delta structure defined on the Databricks environment. So this will help move or do or complete our data model conversion, so that the data structure is available in the target Databricks environment, right? And when we move to the data process migration, is this actually the ETL process, right? When I'm going to move my scoop can be replaced by a parameterized Azure data factory. You might have probably hundreds of scoop scripts, or probably few scripts parameterized. Probably in Azure Data Factory, you could have one package which is completely parameterized to run it in a much more effective way, right? Or so here again, for us to look at the different ETL migration process, what all should I look at? What are the workload types? Where is there parameterization in the existing environment? What are the schedule dependencies? Are there any alerts being done in the existing environment? What is the baseline performance? This is very critical, because to ensure that the target Databricks environment delivers much more performance than an existing Hadoop is very critical. So it's very important that we baseline the current performance, and based on the workload, either it's non-Spark or Spark. If there are already Spark jobs, then if it's an older system, you might have an RDD kind of setup, so which might be better to move to data frames kind of querying model in the new environment. So if it's and say another thing which I've seen is there are certain environments where you might be having cascading and scaling kind of programming, which is better to move to a Scala kind of model. And again, HQL, we have an option now. You can move Delta SQL or Spark SQL kind of queries, whichever is. But based on how it's being consumed, right? And based on that, we could take a call whether you want to run them as Delta SQL queries. And the schedules, again, it could be done within Databricks or ADF or Airflow. We have seen a lot of customers also using Airflow along with Databricks. So that's also an option to look at when you're going to convert the schedules into the target platform. And in terms of validation, I think it's very critical as part of the data process. Unlike the data model, this data process validation requires good amount of in a process to understand the existing and run the new process, understand the existing process and the new process developed, and then run both the things in parallel and see how the output, compare the output of this old and new process, and ensure that the outputs are same, right? And this is where you might some amount of understanding of business very plays a good role in terms of certain things people can clarify by themselves internally. They are going to the business user, right? And the other thing is to ensure that the triggers, any dependencies depend on the existing environment, are also mapped out effectively on the cloud. Especially if it's an on-premise, there could be a lot of dependencies on the on-premise platforms itself, right? You could have another ERP system pushing the data, and you could have some triggers around that. So those has to be defined effectively and ensure that those are validated how they're going to run the cloud, right? And okay, so what we saw now was on the data model and data process, right? And much of the effort could be more on the data process. If you see, 80 to 90% of the migration effort could be on the object conversion, could be on the data process, right? So now for us, it's very important we understand uh, how much of automation can be done in each of those layers, because whatever automation you bring in this data process layer conversion is where you would actually see a lot of value in the overall migration plan or effort. So from what we have seen in terms of customers migrating from different uh, tool sets in Hadoop to Databricks, this is a summary of which kind of tells where the automation feasibility is high and where it's very limited. In fact, if you see Pig, right, your conversion automation is kind of limited. You might end up actually creating some the automation could be probably creating some templates, but the actual code conversion has to be done in a much more uh, rewriting model, right? But scoop to Azure data factory, right? There the automation is much more higher, because once you know what are my tables, what are my sources, what are my targets, what connections I'm using in scope, I can actually parameterize a data ingestion framework on Azure Data Factory, which could be completely, may not be one-to-one conversion, but it could completely lessen your migration effort, right? And similarly for Hive queries also. So your validation can be much more automated, analysis can be completely automated, but your conversion also based on Delta Lake SQL functions and how what kind of Hive queries has been written, the conversion possibility automation is also in Hive to Delta Lake is high. So with this, I would want to hand it over to Vidya to kind of show what kind of analysis can be done in an automated way. We have a couple of dashboards which Vidya will take you through. And then also she will talk about specifically on uh, what kind of HQL to Scala conversion can be done and how we have done some template development as part of the migration process. Vidya, you want to kind of get started, Vidya?
Yeah, sure. I think I have opened up my screen, so I hope it is visible. So here we are going to see some of the analysis or the reporting of what can be done as part of the assessment. Pandian did explain about the entire steps on how about we can do the assessments and how to actually come or arrive at a conclusion on how much of actual code has to be rewritten or automation can be done, right? So how do we arrive at those, right? So we need to do some kind of analysis, and we need some kind of reports or dashboards which shows us how complex is my code based on multiple aspects, right? What are my source types, what are the different targets I need to load, how many DDL scripts are there, what kind of functions I'm using, right? So some many kind of metrics we need in order to capture those details, in order to analyze and come to a conclusion on what kind of effort I need to put in here, right? So uh, this is the report which I'm showing right now. We have done for Hive, right? So we are basically showing the number of scripts, the number of tables, what are the different source types for different applications. So we can click across multiple applications and view, right, what kind of data sets I have, and also analyze the complexity based on that, the different kind of scripts I have. Within those scripts, how many tables are being called, how many columns are there in each of those tables, how many lines of code, and what are the different DDL or DML statements I have in each of those scripts, and across my scripts, or how many tables are being used, and each of these tables where all it is being called, right? All these kind of analysis we need in order to understand the query better and what kind of complexity is there. And once we kind of get through a summary of the different queries and the scripts, we need to do an impact analysis. So what kind of impact analysis can be done based on my scripts? How many tables are there, and from each of these tables, what kind of how it is getting impacted, where all it is being called. Each of my tables, if I have hundreds of tables, where all it is being called, it's kind of tracking the lineage, right? So something of that sort, where you actually get for where my tables are being called and how many places it is being referred to. how many scripts I need to go about manually rewriting the code, or can I do some automation in any of these? So this is the kind of impact analysis which we can do. These can be automated so that when there are 10-15 scripts, it is easy to go and do it one by one. When there are hundreds and thousands of scripts, these kind of automation and analysis actually helps. Also, the script similarity. So there might be redundant code which has been developed due to different kind of people working on it, or different modules. So if you actually put together a system where you can actually analyze these codes and find out their similarity based on design patterns, or based on the programming logic they have used, then it's much easier to see how I can replicate those codes, how I can actually go about rewrite those codes, or use some kind of automation in terms of doing that. So this is what this report which I'm showing right now shows the script similarity. Right now we saw for Hive. Similarly, for Scoop, right? I have uh, my Scoop ETL process, and I can go about analyzing the complexity, query complexity, use it for estimation. The main purpose of having query complexity is to estimate, how quickly I can actually go about converting it from my existing MapReduce or a Hive code and move it into a sparse SQL or a Scala code, right? So that kind of effort estimates can be done based on the complexity levels. Do the impact analysis of my ETL code to find out, right, how many tables are being used and where all it is being called, what kind of impact if I use it in one place or reduce it in the other place. Similarly on the script similarity, right? So here we have just showcased it for Hive and Scoop. Similarly, the Hadoop ecosystem has multiple components, and for each of those, we can go about creating such kind of metadata analysis. We can do analysis and assess the complexity, and then actually go about seeing how actually we can automate the entire process. I think next to this, we would want to go about explaining how we can actually go, convert HiveQL queries to a sparse SQL or a Scala. So for that, I'll shift to the slide mode.
Yeah.
Okay. So for the when we have to go about converting any code, right, from a Hive to a Scala or a sparse SQL, what is the kind of process we follow? First is the object mapping. We go about analyzing the Hive queries, determine, right, what are the different source and target tables we have, what are the different functions we have been used in those queries, how many inner joins are being used, how many outer joins, what kind of DDL, DML operations are being used, where all my files are being referenced, right? So here, basically, we need to do the object mapping, and that's what we have shown below as to how sample query looks like, what kind of functions are being used. For example, in this we have the length function and how it is being used, or the date range and things. And then we have to see how we can actually build a reusable function, right? We actually create these functions or queries which are there. Either we can use a sparse SQL wherever applicable, or we can actually recreate the same functions using Scala, right? So reusable functions helps us so that in wherever it has to be addressed in multiple places, we can actually reuse the same function or the code. And then we go about doing the logic conversion. So we basically analyze what is there in the existing query, and a similar logic is applied, and the code is actually written in another language. So if you see this code snippet below, we are basically showing what is there in HiveQL. We have a toDate function, and the same function, how it looks like when we convert it into a Scala. So object mapping, reusability function, and then the logic conversion. That's the key to basically code conversion process in Hadoop ecosystem.
Yeah. Thanks, Vidya. So I think she covered in terms of how do we do the metadata analysis from Scoop and Hive, and also a use case in terms of a sample code, in terms of how do I convert HQL code to a Scala code. So the other, if you go back to the initial scope of work, right? The other thing which we had, data model, data process, for the interface apps. So interface apps is if you already have some Tableau, Power BI running on Hive, right, or HBase kind of storage. So we could actually now repoint them to Delta Lake as an option. So that's what we are showing on the screen here. Or the other thing which we've also seen in few of our customers is bringing in a virtualization layer. So that's also an option to look at, where then you would actually onboard the existing platform on Denodo and then repoint Denodo to from Hive to Delta Lake. So that kind of ensures there is no impact to the business team in terms of what they see currently. So if you onboard existing Tableau, Power BI, and Denodo, then if Denodo talks to Delta Lake or Hive, that impact will not be visible to the business team. But if you but for us to do that repointing, let's say if you have to repoint Tableau or Power BI from Hive to Delta Lake, there are also options for that, right? Within Tableau, you have to replace data source option, or in Power BI, you can go and do some M code updating. Right? Based on this, also you could actually do a repointing and ensuring that whatever Hive queries are being made available to these reporting platforms, the similar queries are designed and made available in Delta Lake, will ensure that the impact is almost nil when we do this migration, right? And now the other scope of work was data migration, right? In data migration, it's I think to what we initially discussed, right? With Hadoop, it's going to be a large petabyte kind of environment. So it's very important that we look at it three different aspects for the whole migration, right? One is, how do I extract my data from my existing Hadoop environment, especially if it's already maxed out. For the system to provide resource for extraction itself can be a challenge. So it's also again a planning activity, right? To ensure that you are able to extract the data. If there are some backups available, you should refer to that. And if not available, then what time frame I could look at, and what tool sets I could use it to convert to extract the data out, and ensure that it's in a compressed format like Parquet, so that it's easier to transfer. So that the extraction is one part where I will have to decide when to extract, how to compress, and also ensure that I'm able to create some stats for me to do some validation. The second part to it is transfer of data. So especially if it's going to be large volume, you could use data box kind of. If it's going to be offline, then you could use data box kind of feature, or you could do an online transfer as well. But if you're going to do online transfer, then it becomes important that you don't block the network during the business hours. So that's again a planning activity which needs to be worked on along with the network and security. That's the second part of the data transfer activity. The third is loading into the target data lake and ensuring that the data stats and recon. The stats and recon process, again, you could completely reach the Databricks Spark engine to do that recon process, right? So that you're able to do it much more quickly. And then having some recon reports which shows you what data got transferred, doing some checksums in terms of all the rows counts as got migrated to the target platform. So the data migration, we look at it's moving the historical data or the point in time data to the target cloud environment, and doing some recons within the environment. But the other thing is also to ensure that as part of the parallel run process during cutover, we might also have to have the data in sync, right? The other thing which you have seen is as a common challenge is, if there are 10 tables or 10 data sets in Hive, and if you're moving them to the cloud, not all 10 you might move in a single time, right? You might move two of the data sets, and 8 of them, and 2 of them might still be running on an on-prem environment. So getting those data in sync is also one of the data migration plan to be considered. How to keep the data in sync when they're running in parallel, especially when you're not able to replicate the ETL process on-prem to the cloud. So that's also one of the things just to be taken care of as part of the whole migration approach. And the governance and security, at least what we have seen at this point of time, is more of the security, the governance process is completely newly defined in the cloud. We see less opportunity for us to actually do a migration. So probably some user groups, roles, users, you might look at how to create them on the cloud. But there may be a lot other things which are probably has to be done in terms of data classifications, ensuring, especially if you have to use a preview or Unity catalog as part of the new infrastructure. So those things can be looked at. How the queries are going to be fired, right? You might have a lot more tools which are getting to the system. So we'll have to see how those things can be made easily accessible through a proper security and governance. So I think with this, I would want to quickly hand it over to Vidya to cover a couple of few seconds on this success story, Vidya.
Yeah, sure, Pandyan. Thank you. So we saw a detailed explanation of how to go about it, and all this comes from our practical experience, right? So we had a customer who is predominantly in the software industry and who is doing a lot of content creation and product management in that space, and they had a lot of Hadoop systems and the other components within Hadoop as well. Whereas they wanted to move everything into cloud, which is Azure, and in the process we decided to bring in Azure Databricks as a solution, and that's when we actually developed all these and learned a lot of the challenges what we faced helped us to learn a lot of things. So predominantly what the customer was having was a challenges was in the delay in the recommendation systems, or the infrastructure side of it, or difficulty to manage the scoring parameter, right? So how we went about resolving this is using Databricks. So we actually did an end-to-end assessment, and we showed you the metadata analysis reports, right? So Hive queries and how it can be moved into Spark code. So we migrated all of their Hive HQL queries or MapReduce what they had into a Spark or Scala code, the corresponding logic and everything over there. And the data validation between the old and the new process was also performed, and we did a lot of automation to do all the end-to-end activities. So that's how we learned this, and we wanted to share it as part of this webinar with you. I hope it has been useful to one and all.
Yeah, thank you everyone. I hope this session was helpful for you, gave you some ideas and thoughts. So I think we're open for questions at this point of time.
Thanks, Pandyan. Thanks, Vidya, for that quick and very informative session. I know we are 2 minutes already over, but I will just quickly take a couple of questions from the audience. Just before we get into the questions, if you need more information about Hadoop to Azure Databricks, we have a 2 weeks assessment which is listed on the Microsoft Azure Marketplace. Or you can also reach out to us at marketing@winwire.com. We'll be able to share more information with you. So with that, let me first take one quick question. So this is coming from John, where he asks, for migrating from HQL, which is a better option, whether it is a Spark SQL or Scala? Can you just help me understand that?
Okay. Now, I think from what you have seen, if we are looking at a one-to-one kind of conversion to ensure there's not much impact, then Spark SQL might be an option to look at. But we've also seen customers completely re-engineering on a Scala for better performance, because we have seen Spark SQL having multiple joins at times has some performance challenges. So from that perspective, Scala is also being looked at. But again, which is better is definitely to the context of the environment in terms of how complex your queries are.
Great. Thanks, Pandyan. So the other question what I have is, are the metadata reports shown as a part of Microsoft or Databricks? Can you share access to those report files?
So the metadata analysis report, what we showed is actually an IP of WinWire. So we basically created, in order to automate, we did a lot of assessment and we created all these metrics. So we use it as part of our migration initiatives or the migration projects which we have. I hope that answers your question.
Thanks, Vidya. I think it certainly answers. One last question, what I would take for the day is, this comes from Hema. So she basically asked, what is CAF toolkit? Probably Vidya or Pandyan, if you can take, like, it's all about common application development framework.
Yeah, it's a cloud adoption framework toolkit from Microsoft, which Microsoft recommends for any cloud migration engagement. So it's very critical that we follow the whole process to ensure that we are able to adopt all Azure services in a much more effective way. So it's a Microsoft toolkit. for migration to Azure environment.
Thanks a lot, Pandian. Again, thanks everyone for taking time to join this session. I hope you find it informative and useful. If you have any additional questions, please write it to us at marketing@winwire.com. I will let Pandian and Vidya answer those questions. Again, thanks Pandian and thanks Vidya for taking time to deliver this session. It was certainly very useful. Have a good day. Thanks everyone, and happy holidays and happy new year to everyone.
Thank you.
Thank you.